Thanks, Alec. Now that you've explained how the Frisbee flies and how it needs rotation, I'm here to explain the free body diagram. So buckle up, kids, because it's gonna be a bumpy ride. Okay, so he just covered how without an angular momentum, it loses its stability. So what it needs is a very strong angular momentum, and I'm here to show you why. So if we take a Frisbee, and it's flying through the air, and as we covered before, it has an angle of attack. Let's say this is the ground. Now with that angle of attack, it's going to have a center of mass right in the middle. That center of mass is being acted on by mg, and then the lift force, because of its angle of attack, its center of pressure is actually offset, and it's actually further away from the center of mass the larger the angle of attack. So for this, let's just say it's right about here. So that's the center of pressure, and this is the center of mass. See, the center of pressure is where it experiences all the lift. So we have a lift going against mg, and we also have the drag force going backwards. Now if this is the horizontal, and this is the angle of attack, the angle here is alpha. That's the angle of attack. As the angle of attack increases, the center of pressure has a larger distance away from the center of mass. And this distance from the center of pressure and the center of mass creates a torque. The torque is what rotates it and begins to make it tumble. However, if it's spinning like a gyroscope, it has rotational energy, and it's going to resist that change. And this is commonly seen in Frisbees when you fly them, as we just showed you. Now, with that center of pressure over here, that torque causes the Frisbee to tilt left or right at a 90-degree angle. And I'm about to explain that, so keep your seatbelts on. We're going there next.